Alright, so we just finished up this problem. This is part 2 of section 12.2. Let's clear that off. We'll do another problem just like that one. So here, a little different equation. I have some acetylene gas. I'm producing it by adding two things together, water and calcium carbide. I want to know how many grams of acetylene are produced by adding water to 5 grams of calcium carbide. Well, that's very wordy, but all you have to do is, well, this one's pretty easy because there's only one number. So this is my given. Let's get a pen going. My given is 5 grams of CaC2. Okay, so I don't want my given, so I'm always going to start off by writing it down here. Now grams, I can only change grams to one thing, and that's to moles. So I'm going to go moles up here of my same chemical, and I go to my periodic table, and I'm going to look up calcium, and I have one of those, and I'm going to look up carbon, and I have 2 of those. So on my periodic table, calcium has a value of 40.1, rounded to tenths. Carbon has a value of 12. So I'm going to add all those together. Okay, so my molar mass of calcium carbide is 64.1 grams. So I'm going to put that up here. And it's always 1 mole. Always 1 mole. Always 1 mole. Okay, I'm going to cross off the things I don't need. I cancel those out. Now I'm in moles of CaC2. Well, I'm looking for grams of acetylene. And it tells me right there acetylene is C2H2. So that's what I'm trying to get to. So I don't want moles of CaC2. So, since I don't want it, I put it down there to cancel. Now I know my ratio of CaC2 to C2H2. So I'm going to change it to the chemical I do want, acetylene gas. So I'm going from one chemical to another. Now to get those numbers, I just go to my equation. There's no number here, so that's a 1. So C2H2 has a 1. And CaC2 has a 1 as well. Alright, I'm going to cross off my like units. Now I'm in moles of C2H2, but I don't want moles of acetylene, I want grams of acetylene, C2H2. So I got to keep going. So I don't want that. So again, I'm going to put it down here. And from moles, I can go to grams. Alright, so I go to my periodic table. I have 2 carbons. I have 2 hydrogens. I look up carbon on the periodic table. I look up hydrogen on the periodic table. And I add that together. So my molar mass is 26 grams per mole. 26 grams from here, and it's always 1 mole. Cross those off. Go ahead and label this. Grams of C2H2, that's acetylene, that's what the question asks. And then I'm going to multiply that out. So I'm going to multiply 5 times 26 divided by 64.1. My answer is going to be 2.03 grams. Now this, we want to see if it makes sense. Well, I started with 5 grams of something. I end with 2 grams, so I know I'm in the right ballpark. All right, let's do another problem just like that. Go ahead and try this one. Pause it. Try it yourself. When everyone's done, go ahead and start it up and check your work. Now this one has some wording that's a little different. It's talking about how many moles react completely. React completely, not important for us. So just ignore that. That'll come into play later in life. But to start off with, what do we have? We have 49 grams of water. Now, I don't want grams of water, so I'm going to put it down there. My first step, write the given. Second step, put it down there. Now, with grams, the only thing we can change it to is moles. It's always 1 mole. And the molar mass of water, we just go to the periodic table. I have 2. Let me see if I can use my eraser. Oh. Sometimes. Aha! Alright, so I have 2 hydrogens and I have 1 oxygen. I go to my periodic table. Hydrogen is 1, oxygen is 16. And I add those up. 2 plus 16 is, of course, 18. And I take that and I put it up there. So the 1 mole of water has a mass of 18 grams. I'm going to cross off the things I don't need. And I should go back and label this 1 mole of water for every 18 grams of water. Alright, so I don't want moles of water. I want moles of CaC2, so I got to keep going. So I don't want H2O. I do want CaC2. That's what the question's asking for. So to change from one chemical to another, I do a mole-to-mole ratio. And to figure out the ratio of those working, I get 2 H2Os for every 1 CaC2. And I cross off my like units that I don't need anymore. Now I'm in CaC2, but I'm in moles of CaC2. Oh wait, the question says determine how many moles. So that means we're done. So we need to work this out. Now just to show you, because some people confuse the multiplying and dividing, everything on the top gets multiplied. So 49 times 1 times 1. And on the bottom, 18 times 2. Alright, now obviously you don't have to write all that out, but that's just the thinking behind it. And I get 1.36 moles. Alright, here's another, well, a little bit different problem. Now they're asking for molecules of oxygen. Again, just follow the same process. Let's start with the given. I only got one number. I got some grams of water. I don't want grams of water, so I'm going to put it down there. The only thing I can change grams to is 1 mole. Grams to mole. That's molar mass. My numbers, again, just like the last time, I have 2 hydrogens. I have 1 oxygen. That just comes right from my formula. Hydrogen is 1 gram from the periodic table. Oxygen is 16 grams from the periodic table. So 2 at 1, 2 times 1, and 1 times 16. And I add those together. That's my molar mass of water. So I take that 18 grams, and it's always for 1 mole. 1 mole. Okay, I'm going to cross off my similar stuff there I don't need. So now I'm in moles of H2O. I got to look up here. Well, I'm not looking for moles of H2O. I'm looking for molecules, and I'm looking for oxygen. So I want to get out of H2O and into O2. Now, I don't want moles of H2O, so I'll put it down there. I want a different chemical. And the chemical they're asking for is O2. Okay, there's my mole-to-mole ratio, getting out of one chemical into another. How many H2Os? 2. How many O2s? 1. Going to cross off my like units now. Now I'm getting closer. I'm in moles of O2. I want molecules of O2. Alright, so I need another step. Don't want moles of O2. I do want molecules. Molecules. Well, molecules are things. 1 mole of O2 has Avogadro's number of things. I'm going to cross off my like units. Now I'm in molecules of O2. That's what the question is asking for, and so I'm done. Alright, now if I want to calculator all of this, I'm going to take my numbers here, 29.2. I got a 6.02 over there. And on the bottom, I have 18. And I have a 2. So I would calculate all of that. And I can't forget my scientific notation, my 10 to the 23rd. And if I multiply all of that together and divide it, I get 4.88. And I put that on the end. Alright, try this problem, pause the video, work this one out, and then I will do it for you. I'm going to go ahead and stop this video, so continue on to the 3rd video when you have this worked out.